Morning class. Sorry for the delay regarding this video, but for today, we will be actually going back a few steps regarding our discussions here in M0. As you may have remembered, we actually finished discussing regarding atoms, molecules, and ions. And like I said in that video, we will be talking about what we call chemical nomenclature. But by chemical nomenclature, this is actually just stating the name or giving names to what we call chemical compounds. By chemical compounds, may it be ionic compounds, our molecules, or what we call yung may mga covalent bonds and partially covalent bonds. And also, we will be naming some oxoacids or acids bases and also some hydrates. So that will be somehow the overview or the foreshadowing of what we are going to talk about in this video. So in that, we will talk about nomenclature. By chemical nomenclature, there is actually a certain system or a certain way on how we can name certain compounds. Uh, in some way, these compounds actually have what we call common names, like when we are talking about certain organisms in our surroundings. For example, let's say humans. Human in scientific name is actually called sapiens. So in that, the common name will be human or tao, and the scientific name will be the Homo sapien. In chemical compounds, there is actually that system. There exists such system in which we can have some scientific way of naming compounds. So that naming actually differs for ionic compounds, molecules, for oxoacids, for acids, bases, also for organic chemistry. There is a certain way on naming compounds. So how do we arrive at this system? Actually, that system is provided by an association called the UPAC or IUPCA. This is the International Union of Pure and Applied Chemistry. A UPAC is actually found in your periodic table of elements if you have some. So you can this system of naming is actually based on the IUPAC's system of nomenclature. So in that, let's start with the first set of chemical compounds, which we call ionic compounds. As a review, by ionic compounds, these compounds are actually just the combination of often it is a combination of a metal and a non-metal. So by that, this ionic compound is actually bonded or actually possible due to the presence of an ion or our non-metal and the cation, which is our metal. So in naming ionic compounds, we just add IDE or IDE to the element name of the anion. So if we have, for example, we have here barium and we have here chlorine, we just identified an ion, and for this example, the anion will be, or the non-metal will be our chlorine. So for that, we will have there barium chloride. Okay? So another example. Example here, we have here potassium and oxygen. Right? Oxygen here is our non-metal, meaning to say this is just potassium oxide. Okay? Then For example, we have here magnesium, and our anion is our hydroxide, meaning to say this ionic compound is magnesium hydroxide. Okay. And another example we have here, our cation here or metal will be our K or potassium, and our anion will be our nitrate. Okay. Meaning to say this will be potassium nitrate. So as you can see here, then the set of or the general system of just changing the IDE of the anion doesn't apply to all ionic compounds. So basically, when we talk about ionic compound, there is actually what we call the monoatomic, right? Monoatomic ions and polyatomic ions. So for some polyatomic ions like nitrates, carbonates, nitrites, and the like, there is a certain way wherein they are named by using their anion. Okay, we will see that later. So in here, we actually have some other ionic compounds. So in here, actually, we have sodium, which is a monoatomic ion again, and a chlorine. So we just write the name of the metal first. So we have here sodium, all right, and chlorine. So we have here chlor, and then change the rin. So we have here ide, sodium chloride, right? For here, we have here potassium, and we have here bromine. So this will be potassium bromide. Okay, and again, same scenario. We have here calcium, and we have here two atoms of iodide. So this will be calcium iodide. Okay. Next, we have here cesium. Okay. And we have here fluorine. So we'll have here cesium fluoride. Okay. So in that, you get the sense of how we can name other ionic compounds. So in this scenario, actually, if we have here this type of ions, we don't consider the number of atoms when we are naming our ionic compounds. For example, if we have here two iodide, we don't mention that there are actually two atoms in that ionic compound. So for ionic compound, we simply write their their names. There are no quantifiers of some sort to mention the number of atoms of each element or each atom in the ionic compound. So in that, I will be leaving this remaining four examples for you to identify. So please take note of these atoms. This will be actually included in your assignment. All right. So set one will be this Na2O, and we have their CDS, and we have here Mg3N2 and Ca3P2. So you may pause the video to take note of this four ionic compounds, which you will be naming later on. Okay. So going back to our discussion. So for the next part of our discussion, we will be talking about some exceptions to the rule when we talk about what we call ionic compounds. In some cases, we have here what we call transition metals, in which when we are using transition metals in our ionic compounds, we actually indicate the charge on the metal with Roman numerals. For example, we have here this ionic compound. So this ionic compound actually have one iron, and two chlorine atoms. So in that, we can deduce actually that each of the atoms has this charge, wherein the two chlorine atoms has a charge of -2, meaning there's a -1 charge for each an ion. And for the iron, on the notion or on the assumption that ionic compounds should have a neutral charge when they are combined or ionic compounds has neutral charge, meaning to say our iron here has a charge of +2. So in that, since our iron has a charge of +2, we actually name the compound iron 2 chloride. So for other scenario, for example, we have here another ionic compound which has one iron and three chlorine atoms. So in that, the charge of the chlorine is actually stable, meaning to say that should be -1. So we have here three chlorine ions. So three chlorine ions, meaning it has a charge of -3. So ibig sabihin, or meaning to say, our iron also have a charge of +3. And since the iron has a charge of +3, we will be naming this compound or this ionic compound as iron 3 chloride. Okay? Before, there is actually another system or another way of naming these two compounds, wherein the one of this will be the ferric chloride, and the other one will be the ferrous chloride. But that system of naming actually falls under what we call common names. So in that, to avoid confusions regarding the ferric and the ferrous, we use the Roman numerals to indicate the charge of the transition metal. So another example here is we have here chromium and sulfide, if you just name that way. But as you may have remember, chromium may have different charges. So a sulfide, actually, we have here 3 sulfide, which has a charge of -2, meaning to say we have here -6, meaning to say for those two chromium ions, we have a charge of +3. Okay, which is 6 divided by 2, meaning to say this will be chromium 3 sulfide. Okay, just for the overview of what I'm talking about regarding the charges of transition metals, so you may have remembered, these transition metals actually may have different charges. So in here, you may see that chromium has two possible charges. It can be 2 plus or 3 plus. Manganese may have 2 plus or 3 plus. Iron may have 2 plus or 3 plus. Cobalt may have 2 plus and 3 plus. Nickel may be 2 plus or 3 plus. Copper may be plus or +1 and 2 plus. Silver will be just one charge. We have here gold, which may be 1 plus or gold plus. Then we have 3 plus for gold. Also for mercury, it may be 2 plus or which have two atoms, and for the other one we have here 2 plus for a monoatom. Right. And same for selenium. and same for lead. We have here different charges which are both 2 plus or 4 plus. Okay, so that is the basis why we need to first identify the charge of the anion. Then we use the charge of that anion to predict or to calculate the charge of our transition metal. By the way, our transition metal is located here and some are here. Okay. And here are some IDE nomenclature for some common monoatomic ions according to their position in the periodic table. So we have here carbon is carbide, silicon is silicide, nitrogen is nitride. Okay. We have here phosphorus if negative, which is phosphide, and we have here oxide for oxygen, sulfide for sulfur, selenide for selenium, telluride for tellurium, fluoride for fluorine, chloride for chlorine, bromide for bromine, and iodide for iodine. And there's a note here. If we have two carbon atoms and it has a charge of two negative or two minus, it's still called carbide. And here are some names and formulas of some common inorganic cations and anions. So if we have here, if you can even out their charges, they can form what we call ionic compounds. For example, we can have aluminum uh, phosphate. We can also have aluminum thiocyanate and the like. So also some of the polyatomic ions and ions are actually included here. And also we have here the aforementioned common names of some transition metals. We have here for chromium, we have chromic. For copper one, we have cuprous. For copper two, we have cupric. For iron two, we have ferrous. And for iron 3, we have ferric. And also we have, for mercury, we have mercurius. Mercurus pala. For mercury 1. And for mercury 2, we have mercuric. Okay? So, moving on to other set of chemical compounds, we have the molecular compounds. The molecular compounds, these are actually aforementioned in our past videos, wherein these molecular compounds are actually the some examples of molecular compounds are actually covalent bonds and polar covalent bonds. So these are actually just a combination of non-metal plus non-metal. Sorry. Uh, And also, it can be a combination of non-metals plus metalloids or some uh, elements that behaves like metals but are not. And we have here some common names for molecular compounds. Actually, we have here water, we have here ammonia, and we have here methane. Okay? And syempre, when we have common names, we also have scientific names. So elements furthest to the left in the period and closest to the bottom of the group of the periodic table is first place in the formula. Okay, closest to the bottom and furthest to the left. So as you may see here, furthest to the left, ating ano. Then if there are one more, one if there are one more compound can be formed from the same elements, use prefixes to indicate number of each kind of atom. Meaning to say, uh, not like our ionic compounds, we will indicate the number of atoms in each compound. Meaning, say, for example, we have three three chlorine in one molecule or one molecular compound. We will use the word tri. Okay. So for the prefixes, we have here mono for one, di for two, tri for three, tetra for four, penta for five, hexa for six, hepta for seven, octa for eight, nona for nine, deca for 10. If you want to know some other prefixes or Greek prefixes for 11, that will be on decagon for 11, dodo decagon for dododeca for 12. So undeca for 11, trideca for 13, and so on and so forth. Okay? So, and we will still be using the IDE or IDE on the name of the last element. For example, we have here molecular compound, hydrogen, and iodide. If you look into the position of hydrogen and iodide in the periodic table of elements, iodide are actually located at the bottom in comparison with hydrogen, meaning to say this will be hydrogen iodide. Okay. Also, if we have here nitrogen and fluorine, if you look into your periodic table of elements, fluorine is actually located to the right. Meaning to say, we will have here nitrogen trifluoride, tri for the three. Okay? In here, we have here one atom of sulfur and two atoms of oxygen, meaning to say, we'll have here sulfur dioxide. Also, we have here two atoms of nitrogen and four atoms of chlorine, meaning to say this will be our dihydrogen tetrachloride. Di for the di for the two, and tetra for the four. And we have here our NO2. We have here nitrogen dioxide. We have here N2O. We say we have here dinitrogen monoxide. And for the continuation of your assignment, please name the following compounds. You may pause the video. Sorry for the late one. You may pause the video for this six molecular compounds which you will be naming. Okay. In that, uh, this is actually the end somehow of how we can actually name compounds. Okay, and that notion and this is just the end of the common ways of how we can name compounds. Generally, if you know how to name ionic compounds and molecular compounds, the next portion of how to name different types or different other kinds of compounds, the basis of naming of those compounds is actually on naming of ionic compounds and molecular compounds. So in that, this is actually the flowchart or the main concept on how we can name ionic and molecular compounds. All right. So for the next, I will ending the video here for now. So for the next part or the next set of videos, I will be talking about the other types of chemical compounds, which are the oxoacids, the acids, the bases, the hydrates, and the organic compounds. See you in the next video. Bye.